Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So this video we covered more questions on tutorial. Okay, we start with question number 6. You can see that this one is actually current versus time graph, and you can see that this is a sinusoidal graph, and to be exact, this is a sine graph. Okay, figure 6.1 shows the variation of current with time and determine the RMS value of the current. So over here you can gather straightforward some of the information, okay, such as over here you know that this one would be your period. Straight away you know this one is your period, and this one would be your I naught. If this one is V against T, that one would be V naught. Okay, but this one is still period. So one complete cycle is one period. The question number A, they want to find the RMS value of the current. So A equals to I RMS I naught over square root of 2. So this one will be 5 divided by square root of 2, which is equals to 3.54. Okay, the unit, don't forget this one is current, so it will be ampere. Okay, question number B, the supply frequency. So this is the period, which is period equals to 40. Don't forget that this one got unit, this one got unit millisecond, so it will be 40 millisecond, which is equals to 40 times 10 to the power of negative 3 seconds. So the frequency will be 1 over T so this one will be 25. The unit will be hertz. Okay, so you can see from the graph here, you can determine the period, and then from the period you can calculate the frequency. The question C, they want to find the phase in time of 15 millisecond. So the phase phi is equals to omega t, okay, which is equals to, so you have the equation of I equals to I naught sine omega t, where the omega t here is the phase. Okay, so if I were to substitute the values, it will be 2 pi f multiplied with the time here, which is 15 milli. So here I got 2.36 radian. So be careful with the unit. Okay, this one is radian. And the last question for this one will be the expression for the graph. So you can refer to the one that I write over here. Okay, so it depends on the shape of the graph. If this one is cos, you have to use cos, but in this case it's a sine graph. It starts from 0, it goes to positive. You can see the clear S over here. So it is actually a sine graph. So I equals to I naught. Maybe I can just write the general formula first. So what you need to do now is just to substitute I naught and omega. The I and T you leave it like that. So I naught will be equals to 5 sine omega is 2 pi f. So I just write it again in case you didn't notice. So that one will be 50 pi. So you can leave this one in pi, it's okay. And even if you change to decimal place, it will be okay as well. Okay, and then please don't forget to write the unit. Okay, I think you can understand good. This one is 50. Nampak macam S so it's 50. Where okay, this one saya buruk pula. You have to write the unit where I is in A and T in second. Okay. Okay, for question number 7, this one is pretty straightforward. Certain AC of 50 Hz is connected to a bulb rate as 12 volt and 6 watt. The bulb is lit up to its normal brightness. Sketch and label the time graph for this AC. Okay, so the bulb is actually 12 volt and 6 watt. So I already take out the information. I think this one, it will be much better if I put it over here, because this one is the label on the bulb itself. So the bulb, you can represent this one as your resistor lah, in terms of alternating current circuit. So this is your power supply. You have source of 50 Hz. I put it like this. So whenever you try to take out the information, you can always do it like this as well. Sketch and label the current time graph for this AC. So basically you want to show that the variation of current with respect to time. You will expect that the graph would be a sine graph. Okay, and the thing is, you need to label certain things like the period. So if I were to label here, if I were to draw the graph to be like this, so I do need this value over here, and this one represent the period. So you need to find the period, and I need to find the I naught and negative I naught over there. So two things that I need to find, which is period and maximum current. So if I want to use the power formula, so P is equals to IV. Okay, make sure you use VR. In this case, you only have one component, so it could be VRMS as well, but here I just put VR. So the VR is 12 and power is 6. So your IRMS will be equals to power divided by 12, which is 0.5 ampere. This is the value for IRMS. But if you want to put inside here, it should be the values of I naught. So you know that IRMS is equals to I naught over square root of 2. Okay, I can rewrite this one where I naught is equals to square root of 2 multiplied with IRMS, which is 0.5. Here I should get 0.71. Okay, so this is the values of I naught, and you can put it this one as well. Jangan lupa yang negative tu. The unit will be in ampere. Okay, the next one, you need to find the period. You can use the frequency that is given. So F is equals to 1 over T, which is equals to so the frequency is 50 Hz. So T is equals to 1 divided by 50, which is equal to 0.02 second. So you can straight away label here as 0.02, and the unit will be in second. You can change to milli if you want to, but just leave it like this.